Okay, we're going to try this again. I think my recording system had an error. So for this, I'm going to run a correlation analysis. So the three variables we're going to look at is age, height, and weight. And then I'm going to show you how to do it both parametrically and non-parametrically. In SPSS, this is really easy. There's not really a real research question here. It's just more teaching you how to run a correlation. So again, you'll want to check for normal distribution. So you can do that with this phase. Oh, sorry, wrong button. So I can test normality and look at my three variables. And basically I'm going to look at my test for normality, and age is not normally distributed and weight is not normally distributed based on this small sample. So I'm probably going to bias my results or my interpretation of my results from the non-parametric analysis. Right. A lot of statisticians will look at how well it lines up on that age, if it's relatively straight or if it's skewing off the QQ plot angle. So those of you that have taken some stats will have looked at that. It's easier for me to make sense of a significance value. Okay, so to run a correlation, it's really easy. You just go to correlate. We're going to do bivariate correlations. And we're going to put in our three variables. It will do as many variables as you want, and it's always going to coordinate just with two variables. So it's going to do age to height to weight, height to weight. So it's going to give you those outputs. So a Pearson is a parametric analysis. Spearman is a non-parametric analysis. It's that easy to do a parametric or non-parametric analysis. We can look at options, but it can provide means and standard deviations. There's lots of ways that you can get that if you would like to have that information also. It's not necessary for this assignment. And then you hit OK. And voila, there's your non-parametric analysis. And there's your parametric analysis. So it says Pearson correlation, so that indicates that that's a parametric, and then the Spearman row is the non-parametric brethren of that. So if we look at this, since it was non-parametric data, and we look at these two correlations, the correlation is on the top line. So age to age is always going to be 1. It's sort of in this diagonal. Height to height is always going to be 1. Weight to weight is always going to be 1. So the way it sets it up, it looks at age to height, and that says there's not much of a very significant correlation. The R value, or the Spearman row in this case, is negative 0.024, and its significance is very low, so it's way above 0.05. Age to weight, again, not very high correlation, and again, not significant. And you can see up here in this illustration that the data is basically showing the same results with the parametric Pearson correlation. But what we would expect to be the most correlated would be with height and weight, and it is. So it is significant at a 0.65 correlation. So now let's show you what I want you to do with your table in Excel. So when you copy this over, you're going to put this into a format of a table. And so this sort of sets everything up correctly. Notice that we have an N of 23 because we included all the subjects. But this is pretty much exactly what you want it to do. Now, I tend to take the N and the significance out, and then I just put the significance down at the bottom and put an asterisk with that when I do a correlation table. So as we set this up, what we're going to do is we're going to basically make this same table over with a couple few less things. So I just copy that over, and then I'm going to copy, I'm just going to copy and transform that. So now that's always going to be a 1, or you can just leave it blank. This is always going to be a 1. This is always going to be a 1. So the true results are right here in these 2 cells, the 3 cells. So you'll see it reported both ways, with a 1 in there or with it not showing anything. So what we care about the most are these correlations and this correlation. That's basically my table. Put my lines on it. And that'd be a bottom line. And then I'm going to indicate what the double asterisk means. Equals p, equals p-value equal to, or let's do it this way, it'll be less confusing. P equals 0.001. And so that's basically it, and the significant correlation is between height and weight. So I want you to write an interpretation there. So the interpretation is the only significant correlation was between height and weight. Done.